Chapter 1, Lesson 2, Prime Factorization. Our objective for today is that you will use factor trees and ladder diagrams to write the prime factorization of a number. Okay, so our essential question is, how do you write the prime factorization of a number? So let's look at this unlock the problem. Secret codes are often used to send information over the internet. Many of these codes are based on very large numbers. For some codes, a computer must determine the prime factorization of these numbers to decode the information. The prime factorization of a number is the number written as a product of all its prime factors. Now remember right here, for those of you who don't remember what a prime number is, it tells you right here under this remember pin. It says a prime number is a whole number greater than 1 that has exactly 2 factors, itself and 1. So 1 is not a prime number. It does not count. But any other number that only has 2 factors. Now remember, factors are things that are multiplied together. So for example, 3 is a prime number because the only way I can get to 3 using multiplication is 3 times 1. There's no other set of numbers that can get me to 3 if I multiply them together. 6 is not a prime number. It is not a prime number because I can get there by 6 times 1 or 2 times 3. So 6 would not be prime, but 3 would be. Okay? So prime factorization of a number is the number written as a product of all its prime factors. Don't list them. You have to write them as a product. Okay? One way to do this would be use a factor tree. The key for a code is based on the prime factorization of 180. Find the prime factorization of 180. Okay, so looking at this, it says, think 10 times what number is equal to 180. So they kind of have it set up for us, and we're just going to plug it in. So 10 times what equals 180? Well, I know that that is 18. Okay, so 18 times 10 is 180, which means right here, this is what it's saying is 180 is 10 times what? That's 18. We're going to look over here on the left. 10 times 2, or 2 times what equals 10? Good, we're kind of going backwards. So 2 times 5, 2 times 5 equals 10. Now looking down, 5 times what can give me 5? Well, only 5 times 1, which means we're going to just carry down that 5 because there's nothing else. I can't put a line here because 5 is prime. Same thing with the 2. They brought that 2 down because 2 is also prime. Now we're going to look over here on the right side with that 18 because we didn't finish there. 18 is not prime because 6 times what gives me 18? That's 3. 3 times what gives me 3? Only 3 times 1 can be 3, so 3 is prime. 6, on the other hand, like I just explained, 6 times 1 gives me 6, but also 3 times 2 gives me 6. Now, once I get here, I'm just writing all of these numbers as a product, which means multiplication, and I need to put them in order from least to greatest. So the prime factorization of 180 is 2 times 2 times 3 times 3 times 5. Again, I just use these numbers. I got the 2 times 2 times 2 times 3 times 3 times 5. In order from least to greatest and written as a product, which means zeros. Okay, so then another way, that's when we think of using basic math facts. Okay, we can do the same thing, create a tree, but we can use divisible numbers. Okay, so if I think 180 is even, because it's got a 0, so I know it's an even number, so I know automatically it's divisible by 2. So 2 times what gives me 180? Well, I know 2 times 9 is 18, so 2 times 90 equals 180. So that's where I'm going to start off here. I'm going to use 90. Okay, this is showing that you can have 2 different prime factorization trees and they could both be right. Okay, so it's kind of like the estimating. It doesn't have to look exactly like mine as long as it still is correct. But we know that 2 is prime. Okay, so I'm just going to carry that 2 down all the way because we can't ever put another branch on it because it's prime number. Now, what times 2 gives me 90? Well, 45 times 2 gives me 90. Okay, so that 2 is now prime, so I'm carrying it down. 45 divided by 3 gives me what? 15. 3 is prime, so it can't be broken down anymore. 15 is not prime, so I can break that one down even more. 15 can be divided into what two prime numbers? 3 and 5. So if you look, the prime factorization of 180 is written out in two different trees, but they're going to come with the same answer. Look, we got 2 times 2 times 3 times 3 times 5. So the prime factorization of 180 is 2 times 2 times 3 times 3 times 5. Another way to do this, okay? So still prime factorization, that's all we're focusing on today. Because remember what our objective is. Our objective is that you will use factor trees, which we just did, and a ladder diagram to write the prime factorization of a number. Okay, so we're still doing prime factorization, but now we're going to look at that ladder tree, which is what this is that we're looking at right now. Okay, so the key for code is based on the prime factorization of 140. Find the prime factorization of 140. Choose a prime factor of 140. Continue dividing by prime numbers. You can't just pick any number. You have to do by prime factors until the quotient is 1. So once we get down here and we see that it equals 1, we know that we're finished because it can't go anymore. Okay, but you've got to divide by prime factors. So one way that we could do the ladder diagram is to use a divisible rule by 2. So if I look at 140 is the numbers I'm working with, 140 is even, so I know that it is divisible by 2. So 140 divided by 2 equals what? Okay, 70. So if you see I put down here is the 70. 70 divided by what? That has to be prime. Okay, 70 divided by 7, that's an easy one. 7 is prime, 70 divided by 7 is easy math, which gives me 10. Okay, 10 divided by what prime factor gives me 2. 10 divided by 5 gives me 2. I am not done. 2 is prime, but it is not 1. I have to go until the quotient is 1, so I've got to divide again. 2 divided by what gives me 1? 2 divided by 2 gives me 1. So the prime factorization, again, we have to go in order. We do not include 1 because 1 does not count. We don't ever include 1 in prime numbers. Prime number has to be greater than 1. So we use the rest of these numbers over here on the left, but not that number 1. Again, we got to put them in order from least to greatest. So we've got 2 times 2 times 5 times 7. That is the prime factorization of 140. Using the ladder diagram again, let's look at this if we're going to use the rule for 5. Because nobody said we have to use 2 first. 140 ends in a 0, so 140 is divisible with 5. I know that. So I can take 140 divided by 5. So 140 divided by 5 is 28. Okay, you probably have to do guess and check for that. But if I take 140 divided by 5, goes in 2 times, which is 10, 4, bring down the 0, 4 times 8 is 40, minus 40 equals 0. So that's how I knew that. So if I take 28 divided by, they gave me 2 here, so that's what I'm going to use. 28 divided by 2 is 2, 0, bring down the 8, 4, which is 8, so it's 0. So that would be 14 right there. 14 divided by what? Well, over here, I already remembered that 7 was prime, so I'm going to do 7 because I know that will equal 2. 14 divided by 7 equals 2. Again, I'm not done until I get 1 down here. So 2 divided by 2 equals 1. When I'm writing those prime factorizations, I don't include the 1, even though it's there. And I'm going to write these in order. 2 times 2 times 5 times 7. Okay, so remember that we're using that factor tree in basic facts beginning. Okay, so we're going to look at these. Remember what prime factorization means. Okay, prime factorization of a number is the number written as a product of all its prime factors. So here, the prime factorization of 140 is the number written as a product, which means there's multiplication signs, okay, of all its prime factors. So all of these numbers are prime, all of them are factors of 140. A reminder about what a prime number is. A prime number is a whole number, no fractions, no decimals, no remainders, a whole number greater than 1. So that's why we're not writing this 1 in the prime factorization. That has exactly 2 factors, itself and 1. So 2 can only be multiplied by 1 to get 2. There's no other 2 factors that can be multiplied together. 5 can only be found by 5 times 1. 6 is not a prime factor because I can do 3 times 2 and 6 times 1. Quick reminder about what our objective for that lesson is you will use factor trees, which is what we did here. This is a factor, where'd it go? There we go. This is a factor tree. And we use ladder diagrams, which is right here. So we use factor trees and ladder diagrams to write the prime factorization of a number. If you have any questions, please ask your teacher. They would be more than willing to walk through this again, or you can rewatch this video. But please, if you do not understand something, make sure that you ask.